You have joined. Cannot increase it, but it
Yes,
is
sir, it's
readable.
visible, sir. Yes, sir,
Visible,
it's
na?
clear. Yes.
Clear. Okay, okay. Or we can make it view. If you make it view slightly more, let me check whether it is possible or not. Zoom. The paper is now the fiber optic communication, and here you see what are the course objectives. Preliminary, I mean, here for these semiconductor devices and basics of semiconductor devices, these things are, because here in communication there will be different sources, detectors are there, and those are based on semiconductor materials. So knowledge of semiconductor devices is required, as well as since we'll discuss the propagation of light in optical fibers and fiber characteristics. So electromagnetic field theories will be required. Um, I mean, not in details, but a little bit Maxwell's equations. We'll see when we discuss about the modes. That times, you see, we have to take help of the Maxwell's equations. That is the for mode theory particularly. When you, in fact, here in fact, communications, you'll see the light can be considered as rays, and also light can be considered as waves, right? So we'll see it when light will be considered. Light has dual properties, these things are geometrical optics is there, physical optics is there, also some other characteristics are there. So depending on the type of fiber, we'll apply the different concepts. Sometimes we'll apply the geometrical concept, geometrical optics concept. Sometimes we'll apply the wave optics concept, so that you can have the idea of single mode, multi-mode fiber. Right. Mode, when you say mode, means it's a particular field distributions. So that concept we can have it through electromagnetic field theory. So a little bit electromagnetic theories will be used. I think you already have studied electromagnetic field theory. Electromagnetics you have studied in fourth semester, no? Fourth or fifth? Fourth or fifth? Which
Yes,
semester
sir.
you have started?
Sir,
Already have
fourth
started.
semester.
Fourth semester, so no problem. So we are not discussing. I mean, maybe some little bit more theory. That times will be requiring all those things. So the basics are required, prerequisites, and you see what are the objectives here. Actually, initially we'll discuss the different generations of optical fibers. I'll just tell you. There are different generations are there, starting from these. The first generation started with 850 nanometers. Now it is several developments are there that we'll discuss. One class is here for that. That will see it in syllabus, different generations. That times I'll just show you how the different generations have been. Different generations are there for public systems. At present, fourth generations or fifth generation. I mean, it's a mixed now, right? We'll see based on DWDM systems and other advanced devices are used in the latest generation of optical fiber communications. Right, so the different generations will be discussed in this. I mean, that is our objectives to be discussed, and elements required to establish the fiber link. Different elements are there, and also fiber communication is not an ideal system. So some losses, like any other communication systems, some losses would be there. To some extent, we have seen it in data communications losses. Of course, dispersion effect, I have not seen it. That we'll discuss in detail, because light has dispersive, dispersion properties is there. Property is there. So it will affect the data rate, etc. So what are the different aspects? Those are included in this the course, right? Um, you will be able to discuss these dispersion effects in the haptic systems. So this is the first objective. The next objective is this of this course is to identify the types of couplers, optical sources for haptic communication systems. The different types of couplers are there. I mean here it's a directly fiber. If you use a fiber and source, you need some sort of device. Those are actually couplers, not only in the source side but also in the receiver side also. From fiber to the detector, some couplers are required. Right, so there are different types of couplers there. We'll discuss some of them. We'll see it. Right, it can be wavelength selective couplers, or it can be haptic based, or can be other than haptics also can be say conventional optics. It can also be used to couple light from source into the fiber. So there are different types of couplers are there that we'll see, and optical sources. This is most important because here you see transmitter actually based on optical sources. Say what I'm talking, these wire signals, speed signals. This cannot be directly transmitted through optical fiber. You have to convert it into the current fast. Next, it will be used to modulate the optical sources, right? And in the optical fiber, the signal that propagates, it is the optical signal. It is not the electrical signals. So you need some optical sources, and these sources can be, coherent sources, can be incoherent sources. So those are we discussed. Those are included in this course. Right, optical sources can be also sources various types. It can be based on these DH structure, double heterostructures. Probably in semiconductor devices, you have seen these heterostructures. So we'll see it. What is the advantage of heterostructure for making the optical sources that can be used for haptic communication systems. So the second objective, and next third objective is you can identify on the in this course, identify the types of photodiode, or actually a signal that is propagating in this system. It is the optical signal. So in the receiver side, you have to convert it into optical to electricals. So you need some sort of photo detectors. These are actually photodiodes. Right. Apart from photodiodes, some other also devices are also there. But we will focus on photodiodes. That is because these are the fast devices, right? When you consider the extremely high bit rate systems, then other devices will not be compatible. Say other devices like say photoconductors, photomultipliers, those can also be used for detection of light, but photodiodes are the fastest device. That's why these are used for communication systems, right? So we'll see different types of photodiodes, like say pin photodiode, avalanche photodiode. Those things are there. And this is the one component, but actually optical receivers will be there. In the receiver, you see it next is this one optical receiver. This receiver actually it contains the first element photo detector. Next will be amplifiers, the equalizers, the filters, etc. The frequency shaping filters. Those things are also there in the receiver. In fact, receiver is more complex than the transmitter, right? So we'll see how we can we can study the receiver performance in haptic systems when all these components are put together, right? That's what it is here, system performance. And in fact, in this case, to investigate the system performance, it's a haptic link is here. Then if you want to evaluate the system performance, then you have to do the two analysis. You have to perform two analysis, two methods for to apply two methods for this for determining the system performance. One is power budget analysis, and that is rise time budget. That is actually power budget analysis to simply consider the power difference between transmitter and receiver And next, this is allocated to different components. Another is the rise time budget. That is actually, in that case, it considers the dispersion effects. There are different. This is actually used for digital link, the dispersion limitations. Right. There can be material dispersion, waveguide dispersions, intermodal dispersion. Those different dispersion effects are there. So that will limit the bit rate. We'll see how those can be minimized in this case. I mean, those are included in this course. Right. So this is the third objective. The fourth one, you see here, multiplexing schemes are also used. So optical fiber is a huge bandwidth capacity is here. 10 to the power 14 to 15 hertz. I told you in the data communication systems. But still, it can be more bandwidth can be obtained in optical fiber if you consider these kind of multiplexings or WDMs, like say TDMs, TDM, FDMs. Here actually it is WDM, wavelength division multiplexing is used. Different wavelengths can be multiplexed together to increase the bandwidth, right? Which is not possible in other communication systems. Different wavelengths means multiple carriers can be transmitted, but in other communications, multiplexing is here, but sub carriers will be there, but only single carrier is used to transmit the informations. But here, multiple carriers can be transmitted. So if you use 100 wavelengths, so it will be 100 times more bit rate or data rate you can have it in optical fiber systems. So that we'll see what are the, to some extent we have seen the WDM systems, but here we'll see different components. What are the components that can be used for implementing these WDM systems or DWDM systems? Another components, though, when you consider this actual fiber optic networks, when you consider the fiber optic networks, you have to use the optical amplifiers, optical switching. Those components are to be used. Optical amplifiers, to amplify the electrical signals that you have seen it. But here you'll see it how without going to the optical to electrical conversions in the optical domains, how we can amplify the signal. Suppose in a fiber optical signal is propagating, we can amplify it by converting signal optical signal to electrical domains. Next, electrical signal to again optical. Electrical signal can be amplified. Conventional amplifiers, it, right? Next, again, you have to convert it into electrical to optical. So when you do the when you do the conversions, several noise will be incorporated, and that will degrade the signal to noise ratio. So instead, if you perform these amplifications in the optical domains, then far better results you can have it. I mean, you can have very fast systems we can realize. So that we'll see it, optical amplifiers are there. One example, we'll see it, the EDFA, Erbium fiber amplifier is there. It's a fiber. A fiber can also be used as an amplifier. It's portion of fiber. Next, optical switching is the optical switching is most important. It's a very fast. Same things for amplifier switching also. For one channel to another channels, if you do it, then electrical domains you can do it. But instead of electrical converting to electrical domains, directly the information can be switched from one channel to another channels through optical switches. So based on waveguide, interferometric switches, gate switches, that will see it how this switching facility can be obtained, right? And the different aspects are also there. It can be wavelength independent switches or wavelength based switches also are present. And the final, the fifth objectives of this course is to understand the different network topologies. Of course, we have seen this, in data communication systems. Say, to some extent, we have seen it. Say, ring, mesh, bus, etc. Those things are there. But here only we'll focus on fiber optic LAN. LAN topologies. We'll see it. and what are the different aspects of LANs, that will see it. And SONET mostly will focus on SONET networks. That is TDM. SONET, to some extent we have seen it in the last semester, but here also you'll see it here in details. There will be a path switching and line switching. Those things are there in SONET networks, that will see it. Right. So also, if possible, we can see it single hop network, multi hop network, etc. Those things can be discussed. I'll just see what are the things are there in the syllabus. Right. So we'll understand the different network topologies and nonlinear effects in fabric communication systems. So nonlinear effects are also important here because if you increase the data rate, then actually sometimes you have to increase the power. You have to use the generally LED sources are used, but when you want to cover the longer distance, right, or many more stations, then laser sources are used. But when you use the laser sources, then several nonlinear effects will be there, like say Raman effect, stimulated Raman effect, stimulated Bloom effect. Those things will be there. And because of those things, if you use the WDM systems, then some I mean the channels will be not uniformly amplified, right? Some penalty will be required. Power penalty will be there for one channel for different channels. So because of the uneven power distributions, so that will see it Raman effect, Brilliant effect, or four-way mixing. Those things are there in if you want to increase the data rate data rate in fabric systems. So they are the objectives of the courses, and if you learn all those things, you study all those things, then you see what things you can do. After studying all those things, you'll be able to identify the elements required for the fiber link, to establish the fiber link. And also you can determine the loss. Suppose we have designed a fiber systems from certain distance for a certain distance with certain number of components, the splices, connectors, and there are also typical sources, typical say LED source, organizer source, or if you consider a typical fiber, then based on these things, you can determine how much loss is here, or how what will be the data rate, and that can be achieved through your components. So this is the one outcome. Next outcome would be you can choose appropriate couplers or optical sources for your systems. Suppose a particular bitrate systems implemented the 5G systems, then for that 5G systems, you can choose the typical couplers or typical sources depending upon the requirement. Right. Third outcome will be the same way. You can determine, you can select a typical photodiode, whether I told you just now. There can be different types of photodiodes, say pin photodiode, avalanche photodiode, and depending on the power available at the output end of the fibers, you see there are different types of photodiodes there. Suppose if the power is very, very weak, that times you need you have to use avalanche photodiode. So you will discuss in detail their characteristics, and after, if you know all those things, then you can select what type of photodiode will be useful for a particular fabric systems, right? And you can assess the system performance through power budget analysis or rise time budget analysis. The two budget analysis are there. One is link power budget, another is rise time budget. So through this analysis, you can estimate the system performance. So it's the third outcome. Fourth outcome is you can implement this WDM systems. You can optical fiber network. You can implement with these components, WDMs. If you know the characteristics of these components, then you can use say a particular amplifier, particular WDM component, or particular optical switchings. Optical amplifiers can be different types. That one I have mentioned now, 8FA. Apart from 8FA, there can be, there is another one is SOA, semiconductor optical amplifier. So different types of amplifiers are also there. Right, so you can select a particular type of amplifier, particular type of switchings, or particular type of WDM component for a particular network. And final outcome will be you can analyze different network topologies and technology effects in biooptic communication systems. Particularly when you consider the extremely high bit rate systems, then these non effects considered. Like say one generation is here that is based on soliton. So if you that is based on nonlinearity, sometimes nonlinearity is desirables. Nonlinearity generally it is undesirables, but if you can compensate nonlinearity with the dispersion, then another generation of optical fiber realized, that is the soliton systems. Like just like electron proton, soliton system also can be realized in parabolic systems. So they are the outcomes and they are the objectives. Right. Next, you see what are the course contents. So in the module 1, what you'll study the different generations of optical communications. In fact, optical communications, it is a broad terms. We'll focus on haptic communications, because if you say optical communication, then actually optical wireless communication is also there. Li-Fi is there. Visible light communication is here. So undersea communication is here. So different types of communication is there, but we'll focus on these 5T communications. In these generations, I'll just show you how the developments occur in 5T systems, starting from say 850 nanometer, next 1310 nanometers, 1310, next 1550, and next DWDM systems or the soliton systems, like these things. Right? Different generations of optical fiber communications are there. So next, you see in this module, the basic things will be discussed. Like say, what are the components required for a haptic link? The first, the main component for system fiber. So we'll see there are different types of fibers, fiber parameters. In fiber types, you'll see single mode fiber, multi-mode fiber. Also, you can see it in the next line. You can see SI fiber, GI fibers. So step index fiber, graded index fiber. To some extent, we have discussed in the last semester. So now we'll discuss in details, and also what are the materials used for fabrication these fiber to fabricate fibers, or how fiber can be drawn from the materials that will see it. Right. Next, we'll see some theoretical concept of light propagations. I mentioned we can use ray optics analysis, or you can use mode optics. Ray optics generally used for the multimode fiber, and mode optics used for these for single mode fiber. Why it is, that will see it. Wave optics cannot be used for ray optics cannot be used. Wave optics can be used for all cases, but ray optics cannot be used for single mode fiber, because that is the main assumption for ray optics is the wavelength will be tends to wavelength generally it neglects the finiteness of the wavelength of light. In that case, general wavelength is considered as very negligible. Right. Say if you use a camera, camera lens, it has certain dimensions. Camera, if you see conventional camera, it's a 1 inch, 2 inch, like these things. Right. Whereas the wavelength of light, it is say micrometers. Say a visible light, if you see, it is a green, it is 500 nanometers, so 0.5 microns. So you can consider lambda almost zero compared to the dimension of the lens. So in that case, you can use the ray optics. Right. So single mode fiber, you see, it is for multimode fiber, it is quite large, dimension is large. In that context, we can consider the lambda corresponding to zero. But if you consider single mode fiber, with the dimension, with respect to the dimension of single mode fiber, lambda cannot be considered as zero. That will see it. So in this context, when you consider the theoretical aspects, say using the Maxwell's equations, we can have the idea of modes. How many modes? Say fiber is waveguide, so we'll see it, and how we can calculate number of modes in step index fiber or GI fiber. And next we'll see the power flow in step index fibers. Power flow attenuation mechanisms in optical fibers. Optical fibers, you see, it is very, very low loss systems. That's why for very long distance systems, you can use it, but it is not that doesn't mean that fiber optic systems is an lossless system. It is some losses are there. So we'll see what are the different causes of these attenuations. Since the signal is light, so obviously two main causes are there. Will be dispersion and the absorption and scattering. Sorry, dispersion is also there, but that does cause the attenuation. Dispersion will cause the bit rate and degradation in bit rate. Right. Mainly scattering and absorption, those are actually responsible for attenuation. Okay. So this is the module 1. In the next module, module 2, we'll see the different sources, light emitting diodes, and mainly two sources are used in optical fibers, light emitting diodes and laser diodes. These are based. না ওটা ক্যান্সেল করেছি, ক্যান্সেল হয়ে লেখা আছে, মিটিং এ ক্যান্সেল করেছি ওটা। Here we'll see the mainly two types of sources: coherent sources and incoherent sources. Incoherent sources are like LED, light emitting diode, etc. And laser sources are the coherent sources. So we'll see the basic difference between these two sources. When you consider the incoherent sources and when you consider the coherent sources, that are to be discussed, and their materials. It is not the conventional LED used for party systems, because you see here you need high power LED and fast response times. Fast response and high power LED is required. LED or laser diode, both are based on semiconductor materials, so their structure is not the conventional LED. It is actually heterostructure based, right? And that too double heterostructure, heterojunction. So to some extent, we'll see in the direct band gap type materials, those things will be discussed. Next, heterostructures, and then it will be clear their structures and their how we can have high power output, fast response times, optical sources. And also, these sources will be modulated by the modulating signal. So we have to see what are the factors that will affect the modulation capabilities of these sources. So this is the sources. Next, you see in the same models, if you launch power from a particular source to a particular fiber, then you have to see what are the factors that will limit this launching capability. In fact, there are different issues are there: source emission profiles, fiber numerical aperture. Those things are there. In the first module, different fiber parameters are there. On the most important fiber parameters, fiber numerical aperture, apart from fiber attenuations, fiber bandwidth, etc. Numerical aperture is most important. So in the laboratory also will perform this numerical aperture experiment. So those things are there when you launch power into the fiber, right? And to increase this launching capability, some lancing schemes are there. So it can be spherical lens, it can be cylindrical lens, or sometimes you have seen these LEDs are particular shaped, hemispherically domed shaped, truncated sphere, like these things. So listen, different lancing schemes or different specific structures are there to improve the coupling efficiency. That is from source to fiber. Similar things will consider from fiber to fiber coupling efficiency. And also in this module also you'll see different splicing techniques or connecting devices, connecting components. And if you connect one fiber to another fiber, then since fiber is made of glass, so you see skilled persons are required to connect two fibers together. Right. For that, splice machines are used. I mean, that will be based on this the arc discharge, fusion technique, or can be mechanical techniques or some elastic tube technique. There are different techniques are there for connecting two fibers together, or can be a group. A group of fibers can also be connected. Different techniques are there. Here you'll see some differences here on splice and connector. Splice means for permanent connections, and connector means temporary connection. I mean, it can connect it, disconnect it. So we'll see the different types of splicers, different types of connectors. Next module is photoreactors. Just like sources, here also photoreactors can be different types. It can be pin photodiode or can be avalanche photodiode. Pin photodiode, when the power is moderate and sufficient power is here, that times you can use the pin photodiode. But when the power is very weak, that times you have to use the avalanche photodiode. So these things will be discussed in their different parameters, materials, etc. Those things will be discussed. And also we'll see since the communication, so in any communication systems, it is performance is evaluated in terms of bar, bit error rate. Suppose you are transmitting say certain 10 Gbps data, right? Then you see in the receiver, say you will be getting this 10 Gbps, but some of the bits may be in error. So that is actually how much error is here. That can be estimated through bit error rate, right? So some of the bits, I mean bit error, some of the bits, say instead of 0, it can be 1, or instead of 1, it can be 0, like these things. So that is a bar. So number of errors divided by the number of bits transmitted. So that is called the bit error rate. Right. So that can be in a link, can be point-to-point link, or it can be multiplexed links, or can be multi-terminal links, right? And I told you, so all these cases, you have to use two budget analysis, only link per budget analysis and the rise time budget analysis to determine the system performance, right? System performance means, so suppose you have designed link systems with some components, but your performance does not meet the requirement, right? That times you have to change the components. So how we'll do that? That will be based on this power budget analysis or the rise time budget analysis. So this is third modules. In the fourth models, we'll see mainly we focus on different components like WDM systems, DWDM systems, dense wavelength division multiplexings. When many wavelengths are there, more than 16 wavelengths, that time it is called dense wavelength division multiplexings. And different couplers, fiber bracketings are there. They are the different advanced type of components that are used for fiber optic network, add-drop multiplexers, optical amplifiers, etc., etc., 8FA, optical switches, wavelength converters. So those things will be discussed in these models. They are the advanced type of components. Right? In the present day network, it is these are actually used for multiplexing, for demultiplexing, for add drop multiplexing. Suppose you want to drop some wavelengths, you can add some wavelengths. So you need one type of multiplexer that is called add drop multiplexer, that is using fiber bracketing can be realized. So those things are there. This is the fourth module. And in the fifth module, mainly we'll focus on the networks and nonlinear effects that I have discussed. So in the network topology, generally we'll consider the SONET. It is a TDM system, synchronous optical network, synchronous digital hierarchy, SDH. SONET generally it is in US, and in India, in other countries, it is used actually. Term is used SDH. Right. So we'll focus on SONET rings. And when it comes to the ring networks, there can be two types of switching. Will be there can be line switching, can be path switching. So we'll see what are those things in the ring networks. And also you can have other type of networks, all optical WDM networks. That can be single hop networks, can be multi-hop networks. Multi-hop networks means that from source to destinations, there in some stations there can be conversions, optical to electricals. Right, some conversion will be there. That is a multi-hop network. Right, a single hop network, there is no such conversions. So there will be some advantages, disadvantages of these networks that we'll see it. And nonlinear effects, I told you, if when you go for extremely high bitrate systems, then some Raman effect, SRS means stimulated Raman scattering, SBS means stimulated Raman scattering, SPM, self-phase modulations. These are to be considered, right? And finally, we'll see in the soliton concept. Sometime just now I mentioned soliton concept is here. When you consider the nonlinear effects with the dispersion, then soliton pulse can be generated within the fibers. And if it is based on soliton pulse, then several thousand kilometers there will be no need of repeaters. So that will see what is solitons, how soliton based communication is realized in optical fiber systems. So there are the different models. I've given some introductions to each modules, and the books mainly will follow the Kaiser. Of course, Kaiser, the two versions are there. One is the black paper coverage. Another is white paper coverage, white paper back. Right. The two one is third editions, one maybe of maybe fourth editions that will see it. Right. The two models, two editions are there for the Kaizers. Senior also is here, most important. For networking, Goralski is important, but mostly you will follow the Kaizers. If the two editions of Kaizers are considered, then it will cover 90% of this syllabus, 95%, more than 90% will covers. So this is, but other books are also there. Fireplace by Kotok and the optical communications by French and Jen. Some other books also you can see it. Plenty of books are there nowadays, and some Indian author books are there, but those are not so useful for this course. But for reference, you can see it. So this is all about these ones. If you have any questions, anybody you can ask, please feel free to discuss regarding this course or any other things. Mr. Vardhan, any others regarding these things? Any questions? आज तो कुछ बोलो. जनरली तो तुम लोग कुछ पूछते नहीं हो, आज तो पूछो कुछ फास्ट है।
नो सर। सर आप बुक्स थोड़ा अपलोड कर सकते हैं सर, वॉट एवर बुक्स इफ यू आर टीचिंग फ्रॉम कैन यू अपलोड इट?
अगर सॉफ्ट कॉपी है तो हम अपलोड कर देंगे।
यस
सॉफ्ट
सर,
कॉपी है ना?
यस सर, यस
वो ब्लैक पेपर वाला, ब्लैक पेपर का बैक जो है वो
यस
शायद है। व्हाइट वाला शायद नहीं है, तो लोग कहीं पे मैनेज करना, वो कभी इंटरनेट में मिलता है, कभी कभी मिलता है।
यस
तो
सर,
एक पर्सन है जो हम कर देंगे,
यस
है
सर,
ना?
हाँ सर।
बाकी लोग कुछ बोलो। अभिक, अभिषेक।